Hi everyone, so I'm Megan and I'm going to present quickly what I have so far for my project, which I like to call the arthropod weathermen. So for some background, climate change is considered by many as the most challenging phenomenon to understand within ecology. We especially need to gain a solid understanding of the effects of climate change on insect populations because of the vital role that they play in the functioning of our ecosystems. So just like temperature and precipitation vary spatially, insect responses to these climate variables can vary both spatially and between taxonomic groupings. So for example, typically temperature has a positive relationship with insect abundance, whereas precipitation has a negative relationship. So the figure on the left shows some common insect responses to increases in temperature, and the figure on the right shows some common insect responses to changes in precipitation. So I got my hands on 18 years worth of insect abundance data from the Copenhagen Zoological Museum, which is pictured at the top right. They collected insect abundance data from 1992 to 2009 from a singular Robinson light trap, like the one pictured at the bottom right. So I wanted to answer the question of what are the effects of local temperature and precipitation on insect abundance within the city. The city is a pretty mild temperatured but really rainy location, so I was really interested in the results of this. In addition, this type of long-term monitoring data is rare, and so it provides a unique opportunity to measure community trends. So here's a flowchart of my methods, which you don't have to read, it's just there for visuals. So the insects were originally trapped in a light trap and then classified and counted to the species level every 10 days. However, I'm just looking at the family level for the orders Coleoptera and Lepidoptera, as well as only monthly and yearly counts for these families. I also only incorporated families that had at least one monthly count that was above 50 individuals to narrow down the number of groups that I was looking at. Finally, I collected monthly average temperature and precipitation from Climate EU for the city of Copenhagen, and I joined it with the insect data for each respective year and month. So if we look quickly at the monthly average temperatures of Copenhagen, the y-axis is the average temperature in degrees Celsius, and the x-axis are the months. I also forgot to mention I'm only looking at the months of April to November because those were the timeframes that the traps were consistently run. So monthly average temperature varies a little bit between, within years, between months, but it doesn't vary to a large degree between years. I did the same thing with monthly average precipitation. So that y-axis is now precipitation in millimeters. And although there's a lot of variation within each year, between years, the overall precipitation is fairly consistent. So then I plotted the monthly Coleop and Lepidopteran counts. So this is all of the years grouped together, all of the families grouped together as well, but it's separated by month. We can see that July and August both have the largest insect abundance for both orders, and they also have the largest variation of all the months. So then what I did is I split up those counts for each order by family. So there's a plot for each family now. And then I also added all the months together and I looked at the yearly counts and how it changed over time. So the y-axis is year and the y-axis is insect count and the x-axis is year. So in the order Coleoptera, we can see that there are some strong boom and bust patterns in the yearly counts, especially in the highly abundant families like Carabidae and Staphylinidae, whereas in the order Lepidoptera, we don't see this same trend. It's also important to note there's no consistent decline or increase in overall insect abundance over time. We're just seeing yearly and seasonal patterns. So then I split the data one more time. I separated each yearly family count into monthly family counts. And I also split the temperature into average monthly temperature, like I collected from Climate EU. So the x-axis is that monthly average temperature, and the y-axis is the monthly count for each family. So we see that above 17.5 degrees Celsius, there appears to be an exponential increase in insect abundance as temperature increases. And this is more prevalent in the highly abundant families like Carabidae and Staphylinidae within the order Coleoptera. So I did the same thing for precipitation. So now the y-axis is monthly average, the x-axis is monthly average precipitation, but there's no clear trends. So the take-home message that I'm also going to bring with me as I move forward in this project is that there are some potential temperature dependencies for both orders in relation to the monthly insect counts. But with precipitation, there doesn't appear to be any dependency. And then for some insight from my research and from other work is that there's maybe some other ecological processes going on that we aren't looking at in the climate variables. Or maybe there's even some masking of climate dependencies because of spatial characteristics of the city of Copenhagen that are buffering the changes that we should be seeing. So these need to be further explored as I work more on this project. So I just wanted to end it off with this moth who was counted 6 times within the 18 years of the data. It is Enomus alniaria, and he is looking better than I am after working all night to finish this project. Thank you for watching. Definitely visit my website. This wasn't enough time to explain everything. But yeah, contact me if you have any questions. Thanks.